I'll be talking you through the wide-ranging topic of sustainable materials. So yeah, and then we'll have hopefully a few minutes for questions at the end. So quickly, I'm from John Lefebvre, which is the consultancy division of Eurovia in the UK, and we cover all aspects of highway materials really. So material production and design, contracting, some term service and PPP or PFI contracts, and then a couple of joint ventures, Ringway, Jacobs and Bear in Scotland. So we cover the full area of the UK from Scotland to the Isle of Wight and everywhere in between. So the first point I wanted to touch on with sustainability is it's all very well using recycled this and recycled that and not having any virgin material in. But if it only lasts half as long, then really is it any more sustainable? So one of the main points that I think we should be looking more on is asset management and sustainability in terms of financial as well. So looking at a low-cost intervention that's less reactive maintenance, so less impact on your clients, on your on the residents of the general area of the area, and looking at the whole life costing by having an intervention early on, instead of waiting for a high-cost intervention that's more reactive maintenance, reduced safety. So compared to the previous example, if we have minor interventions, so using other treatments such as surface treatments, resurfacing, rather than just waiting for a more deeper treatment. So we're looking at correctly timed interventions with the right material, having a resilient asset management strategy with the known asset condition. So I think it was mentioned in the first presentation today about actually can we know the condition of our material and treating it based on condition rather than just a timed intervention. And then we can increase our social sustainability by having a higher public satisfaction. So one of my key points is they're not exactly the same, but they are intrinsically linked. Today is World Quality Day, just as it happens. So can we increase the durability of our products through increased quality, whether that's looking at the temperature we're laying it in, how we're laying it, how we train our crews, the type of material and aggregate we're using, do they actually link together? So if you can make the same material last half its life again, you've already made a 50% CO2 reduction. And I nicked this from Gorilla Tape, I think, but I think it says the point I'm trying to make. Can we be tough through the extreme conditions that we have? So now, looking on actually what you might call sustainable materials or something a bit different. So many of you may have already come across a cold recycled bound material. In Eurovia, we call it Recofoam. And that's a type of material where you can use up to 90% wrap. So it's a common way to utilize recycled material within the carriageway in the base or binder course. So it is installed at ambient temperature. So you've also got the CO2 saving from heating the material. And it's also got the benefit of being able to incorporate waste products such as incinerator blast furnace slag that you obviously get from incinerator products, but also to encapsulate asphalt waste containing coal tar. So some of you might be aware of the issues that, or the long-term issues that we might face with coal tar products. It was identified as a carcinogenic product, and so we now don't heat the material. So if we want to use it again, we need to incorporate it in a way where we can use it at cold temperature. And that's how Recofoam or cold recycled bound materials can do that. It's also got the benefit of preventing it going to hazardous waste. And so instead of a traditional solution where you would remove your hazardous waste coal tar and take it to landfill and replace it with virgin asphalt material, we can now do a base and binder course of a Recofoam layer and then top it off with a virgin asphalt surface course. And that not only with the CO2 savings, but it gives you an 80% cost saving as well. So that's where we're looking at not just sustainability in terms of environmental, but in sustainability in terms of our financial requirements as well. And so we can identify the tar, then we can split plane it, so make sure you can plane separately your hazardous material from your non-hazardous material, making sure that, again, we're not creating a longer term issue for ourselves. But looking at the future on that, can we go even further? And so the future is a 100% recycled road. And I mentioned it earlier, recycling is not necessarily a cheaper option, but it is a sustainable option. We've got to get over the issue that a recycled road is inferior. It doesn't have to be. It can be just as good, just as long-lasting, just as well-performing as a road using completely virgin materials. And another thing, don't be misled into placing other waste products into your network. If you're in the first session in here, Helen mentioned it earlier, there's an awful lot of press about can we reuse plastics here, there and everywhere. But if we just chuck a load of plastics into our road, one, is that actually giving us a benefit in the durability of that material? But two, is it just causing us a further issue down the line? How are we going to reuse that plastic material? Do we have an issue of microplastics from runoff of plastic in the asphalt? So I think it's a very easy way to gain press attention to just say, yes, we can reuse plastic or other materials, but we do need to think about our longer term implications. So there has been a trial of the 100% recycled road. As you can see in the binder and surface course, it's not quite strictly true, but anyway, the marketing guys say it should be 100%, so we'll keep it like that. But this was a project in southwest France that was for the Route de Future, excuse my French pronunciation, project. And this uses, it's a parallel drying flow to effectively granulate your recycled material down into its constituent products. So it's actually taking your very expensive, high-quality aggregate that you might have in your surface course and taking it back to the coarse aggregate section. Because if you granulate it down, you can then refractionate your asphalt material into the coarse particles, your fine materials, and so on, all the way through. So you can recover your high PSV, expensive asphalt that, okay, one side of the aggregate might have been polished during trafficking for the last 10 years, but you've got maybe 30 or 40 mil of that really expensive aggregate that's never been open to traffic. And it's such a waste to just chuck that back into a base or binder course where it's not its value. We're not achieving its value. So there's an awful lot of research, and other companies such as Conway are looking at it as well. How can we prove that these materials are just as good as they were 10 years ago when we first put them in? And so one of the issues we're looking to do or to research and to prove is how can we make the binder as good now as it was, or perform as well. And so that's why maybe in your surface course you're not quite up to 100% because of the oxidization process and the aging process that bitumen will go through due to its exposure to UV light or to oxygen. And so one of the most important things is when you have a recycled material that you're putting in and you throw in a load of virgin bitumen that you think, great, it's going to rejuvenate my material, it's going to work just as well, is actually how homogeneous is this material? Because you've got a load of really stiff bitumen that's been there for, I don't know how long, 10, 12 years, and you've got this really soft, brand new, shiny bitumen that you're throwing in. But what could happen is you get your old bitumen, and then you just get your new bitumen covering it, coating around the edge. But what we need to do is to try and develop our bitumens and develop our mixing process and manufacture process of the material so we get the homogeneity. So your old bitumen can mix with your new bitumen and give you that long-lasting performance. There are various different ways you can test that, all which are way too technical for me. But effectively, you're trying to prove that it's not brittle and also it's not too soft that it ruts. So you're looking for that perfect middle point. So moving on a little bit to another sustainable topic is warm mix asphalt. So you may have heard of warm mix asphalt before, but this is producing ordinary asphalt as you and I would know it, but at a 30 to 50 degree temperature reduction. So there are various ways of doing this. Eurovia call it a Tempera material, but again, it's widely used out there. And you can use an additive to increase the adhesion between the bitumen and the aggregate, and also to increase the workability of the material. So you get that workability, but with a lower temperature. And so with your reduction in heating, you're not only reducing the temperature you mix it, but you're reducing how much energy has to go in to heat all the aggregates, heat all the plant up to that temperature. And so as part of that, you can get up to a 30% reduction in CO2 emissions just from the reduction in temperature. You've also got that increased benefit with cost as well, because you're using a lot less energy. A really important benefit of this is reduced fumes. And this was touched on in our air quality requirements in one of the presentations earlier on. But for every 10 degrees in asphalt temperature reduction, you get a 50% reduction in fumes. So for the guys working on the site, that is a major benefit to them. I think in the future there's going to be an awful lot more regulation about what we are subjecting our operatives to on the site. And there's going to be an awful lot more testing as part of that. And so if we can it's quite simple, just reduce the temperature, we're already giving them such a better working environment to be in. An additional benefit I mentioned earlier about if you have an oxidized or old bitumen surface, it can get stiffer and more brittle. One of the ways that happens initially is through the mixing time. So a bitumen is categorized on its penetration grade. So the softer it is, the higher the penetration value. So during its storage in the tank, it will slowly oxidize, slowly get a bit stiffer, but it's nothing to worry about. And then during your mixing time, this is when you heat it up. So it oxidizes, it becomes stiffer, and you drop a few penetration grades ready for when you lay it. And then over time, due to our UV light, our oxidization process, it becomes stiffer and stiffer and stiffer until it reaches its critical viscosity, where you get your cracking, your fretting, the dreaded pothole that everyone is so scared of. But if we spend a bit less, or if we heat it up a little bit less, we can reduce this. Okay, and I appreciate this is a very simplified graph, but we can reduce this impact on the stiffness of the bitumen, and we can just give it that little bit extra. So not only are we using less energy, less CO2 in the first place, but we actually might increase the durability of the material and make it last just that little bit longer. Okay, and moving on to my final sustainability topic is moving away from the environmental and more on the social sustainability. There is a massive issue at the minute about noise, and we're starting to gain more traction. But in the UK, 12 million people are affected by noise pollution. And I mean, okay, we're all affected by noise, but this is to an extent where it's actually having a detrimental impact on their health. So prolonged exposure has been proven to affect child development, increased stress levels, higher blood pressure, and heart disease. And one of the main ways that you've got your engine noise, but one of the biggest impacts on road noise is from the air pressure being blown out by the tyre and the interaction between the tyre and the road surface. So as the tyre comes round, the air is pumped out and it creates that rushing noise that you'll hear either if you're at the side of the road or in the car itself. One of the ways that we can do this is branded Ultraphone and Eurovia, but again, there's many other options, is through a low noise surfacing. And there are different ways to reduce the noise output from a road surface interaction with your tyre. But this particular example uses a 0 to 6, which means the aggregate range is from 0, or very small, to 6 millimeters. And it's a gap graded, so it means it's a voided material with interconnecting voids. And how it does that is the air pressure then has somewhere to go, and it can be absorbed by the void network by the large number of small voids within the asphalt. Using the 6 mil aggregate has the added advantage of giving you an increased or enhanced skid resistance, and that's because you have a lot more areas of interaction with your tyre. So they're smaller, each individual area is smaller, there's a lot more of them, so they produce a greater level of friction between your tyre and your aggregates. So this particular material gave us almost a 6 decibel noise reduction, which is equivalent to 75% reduction in traffic. And a couple of, the marketing team made me put this in, a couple of quotes just to show that actually road noise, if you live right next to a busy road, can have a huge impact on how happy you are there. And just one example, hopefully this will play. This is an example from the M1. So you're on your concrete surfacing at the minute. And then this is the low noise surfacing. So it can make a difference, and it can make a very big difference to either the enjoyment of your journey or how happy you are to live next to your busy road. Okay, so a very quick run through, and I hope you don't feel I've rushed it too much, of the different potential options there are out there. And now there are so many more options, so many different recycled materials we can use. But one of the biggest things that I would encourage you to take away from this is that there's no point being sustainable with your recycling, with your use of hazardous products to prevent landfill, if your material is not going to last as long. And I think that's something that we really need to get across to the industry and to the guys on site, that the quality is important. And not just for the sustainability, but for our industry to move forward and to show that we are taking this seriously. So thank you very much for listening.